Welcome. Each month I give a summary of the activity on the Sun in the previous month, and this video covers the month of June 2020. It's been an interesting month with the Sun going into transition. We've seen more and more activity associated with the new solar cycle 25, and less activity associated with the old cycle, solar cycle 24. So what are we going to talk about today? First of all, the decline of solar cycle 24 and the equivalent increase in the sunspot groups associated with solar cycle 25. We're going to have videos taken at various wavelengths, i.e. different temperatures, showing the activity on the Sun during this month. And then we're going to get into some predictions. Now, on the right here, we have the official NASA and NOAA prediction of solar cycle 25. They believe it's going to be slightly larger than solar cycle 24 and peak sometime in 2025. Now you'll hear other predictions coming out of different scientists, some of which may be associated with NASA, but these are not official NASA predictions. You're looking at the official predictions right here and now. The first thing to notice is that the number of sunspots is steadily increasing. In June we had 7 new sunspot groups. One of those was associated with solar cycle 24, but 6 were associated with solar cycle 25. 4 of those groups were in the northern hemisphere, and 3 of them in the southern hemisphere. Year to date, we've had 24 new sunspot groups, 4 from solar cycle 24 and 20 from solar cycle 25. 11 of those were in the northern hemisphere and 13 of those in the southern hemisphere. And we also had 2 M flares back in May. Now to compare that with the whole of 2019, we only had 34 new sunspot regions in the year. 23 of them were in solar cycle 24, but 11 of them were for solar cycle 25. So that's a complete reversal compared with this year. 23 of those were in the northern hemisphere and 11 were in the southern hemisphere, and we had no flares. So the overall number of sunspots are increasing, and the emphasis on solar cycle 25 is increasing. On the right here we have the picture of the Sun on the 6th of June. You can see there's a nice little spot region in the southeast. And when you look at that from a magnetogram point of view, you see that negative polarity is leading. And this is also at high latitude, which means this must be a solar cycle 25 region. We can see this switch over between solar cycle 24 and solar cycle 25 by looking at the number of regions that had sunspots in each year. In blue here is shown the number of regions each month that had associations with solar cycle 24. That obviously follows a declining curve like this. In orange are the number of regions associated with solar cycle 25, and that is showing the opposite trend, an increase. So you can make some predictions based on this. We can predict that there will be over 50 regions from solar cycle 25 this coming year, 2020. That compares with 11 in 2019. And I suspect there'll be less than 10 solar cycle 24 regions in this coming year. That compares with 23 last year. Similarly, another issue is sunspot lifetimes. Now at the moment, even now, solar cycle 24 regions are lasting longer than solar cycle 25. However, by the end of the year, I think that the solar cycle regions will be lasting more than 5 days on average. The solar cycle 24 regions will be less than 3 days. That compares with 7 days last year. So what we're seeing is an increase in solar cycle 25 regions, both in the numbers and longevity, and a decrease in those same 2 parameters for solar cycle 24 regions. There's another way of looking at this, but with better statistics, and that's to use magnetic bipoles. Now these are like miniature active regions, except for they're not strong enough or big enough to produce a sunspot. However, they do have a polarity, and you can check whether they use a solar cycle 24 or solar cycle 25. So back in January of 2019, we had about 800 of these regions on the Sun in a month. But only 37% of those were associated with solar cycle 25. By September and October of 2019, that number dropped to about 300. But since then, the numbers have been steadily increasing, and we're back to nearly 900 such regions per month, and 61% of those are now associated with solar cycle 25. So this is a complete reversal of the situation back in the beginning of 2019. Now let's start looking at some movies of the Sun over the last month. First one is a magnetogram from the Solar Dynamics Observatory HMI instrument. This shows the magnetic field on the Sun, and you can see there are two major regions on the Sun at this particular image. Both are new cycle regions because positive polarity white is leading in the northern hemisphere and negative polarity dark is leading in the southern hemisphere. Those are indicators of new cycle regions. They're both at high latitudes as well, which is yet another indicator. So enjoy the movie. If we want to look at higher temperature emissions on the Sun, we have to go to a different instrument on the Solar Dynamics Observatory, and that's the AIA instrument. That looks at 7 different lines with much higher temperatures, and we're going to look at a few of those here. You can see the helium-2 has a temperature of about 50,000 degrees. The iron-12 has a temperature of just over 1,000,000 degrees. The iron-16 line at 2.5 million degrees, and the iron-20 line at about 10 million degrees. So we're going to take a look at each of those in turn and see what the Sun looked like over this last month in those lines. Our first movie is the helium-2 304 movie. This is plasma at about 50,000 degrees, and in all of these movies about 1 day equals 1 second. The thing to look for here are structures like this above the limb. These are called prominences, and they are 50,000 degree temperature material suspended in 1,000,000 degree temperature. The only reason that works is it's insulated by the magnetic fields. You can actually see some indication of the arch magnetic fields in this picture. Other times you'll see a brightening on the surface of the Sun followed by some ejecta like this, and these often lead to coronal mass ejection, so look out for those as well. Next we move to a somewhat higher temperature of about 1.2 million degrees with the iron-12 line. Now the thing to look out for here are these bright areas, as you can see on the left of the picture, which is an active region. This is generally associated with sunspots. But don't ignore the quiet Sun, which is the area around it, because you'll see that just about everywhere the Sun is doing something. Also you'll see some dark areas, particularly near the poles, and these are coronal holes. These are the origin of the very high-speed solar wind. Next we move to yet a higher temperature of about 2.5 million degrees, and this is really high temperature coronal plasma, such as those associated with sunspot regions. So looking at this movie, the bright areas are ones associated with the sunspots. Lastly, we move to our highest temperature channel. That's the iron 20 line. That's about 10 million degrees. So you're really looking at flares here. Now the trick with this is that there is also a relatively cool line in the same complex as the iron 20 line. So we see simultaneously the cool plasma, which you can see here as these high loops, as well as flares, which you see as bright kernels at the base of those loops. Last but not least, we're going to move to the outer corona, and for that we have to go to a different spacecraft, SOHO, and a different instrument, LASCO. This is a coronagraph which produces a false eclipse of the Sun. In these images, the Sun is shown about this sort of size compared to the occulting disk, which is the disk that blocks out the bright emissions from the Sun, enables us to see this very tenuous, faint outer corona, which is shown here in red. In the corona are these streamers, and sometimes you'll see ejections going along these streamers. Now I'm going to run the movie twice so you can concentrate on the left hand side of the image first time through, that's the east limb, and on the right hand side of the image, the west limb, the second time through. And I think you'll find there's a lot of coronal mass ejections there, and they've been quite a bit more active than they have in some of the previous videos I've shown you. Last week I did a video showing that the number of spotless days between two cycles has no relationship to the peak of the following cycle, as some claimed. Now I said in that this current cycle was nothing special, and in fact the previous cycle was in fact lower. Somebody called WHEELBARGER came in and said that the current solar cycle is the lowest ever. And so I did an analysis by special request to see whether that in fact was the case. I countered his argument with the total solar radiance as measured by the source instrument, and as you can see, the minimum of 2008-2009 had a much lower total solar radiance than the current minimum. But he rightly pointed out that we were talking sunspots, not total solar radiance, although the two are supposedly linked. So I went back and I took the sunspot number at minimum and compared it to the maximum of the following cycle to see whether there was any relationship at all. And this is the plot I got. So you can see there's possibly a loose correlation. You can see the dotted line there, which is a linear fit to this particular data. But there's a lot of scatter in these plots, and you could be fooling yourself. So the only way to check that is to calculate the correlation coefficient. And the correlation coefficient here is 0.49, which is a very poor correlation. You have to be about 0.8 to be a reasonable correlation. So the sunspot number at the peak of the next cycle is not correlated reliably with the sunspot number at the previous minimum. So the level of sunspots at that minimum is not actually an indicator of future sunspot activity. But say it was, what would this prediction show us? This is where we are at the moment, about 2.4 as the sunspot number at minimum. First of all, you can see there are 4 other cycles that have lower sunspot numbers, and none of those led to grand solar minima, by the way. So what would that mean as far as a prediction was concerned? That would give us something like this, which would be a prediction of about 150 plus or minus 70, which would be 80 to 220. And that is basically a useless prediction because that encompasses about 80% of all the cycle values that we've ever seen. So this isn't a prediction at all, and that's why the correlation coefficient is not very good. So we can safely say that, first of all, this minimum wasn't the lowest, and even so, that's no indicator of what the next solar cycle is going to be. I got a second request as a result of that video from someone called KATH Miller, and she suggested that the length of the solar cycle should be correlated against the size of the next maximum. Now, I've been meaning to do this for a number of years, just never got around to doing it, so her request got me off my duff and made me do it. And it turned out to be a very good idea. So how do you do this? Well, first of all, you have to set a threshold to determine when you are in or out of minimum. So what I did here is I set an arbitrary number of 25. I actually tried several combinations, but 25 seemed to be about the best. Then I measured the first time during the decay of the previous cycle that the number dropped below 25, and then the last time it dropped below 25 on the rise of the following cycle, and measured the time between those two, and did that for each cycle of the 24 cycles that we have. So what result did I get? And this is the plot that I ended up with. So I've got the sunspot number at the peak of the next cycle on the left, and the number of months that the minimum was below 25 along the bottom here, along the x-axis. And you can see that this correlation plot is much tighter than any of the previous ones, and the least squares fit I've done to that showed by the dotted line. So again, to make sure we're not fooling ourselves, we have to calculate the correlation coefficient, and that came out to be minus 0.81. Minus means that it's an anti-correlation, so the longer the period, the lower the next peak would be. 0.81 is just above the threshold of goodness, so it's an okay fit. It's not a brilliant fit, but nonetheless it's better than what we've got before, and we can make predictions from this. This is where we are currently at about 50, and if you put a line where it crosses the best fit, you get a prediction of something like 170 with plus or minus 50. That's a bit tighter than the previous one, so we could say that the number between 120 and 200 is probably okay, but it's still fairly uncertain. The thing is, of course, we aren't fully through our current cycle yet, so that dotted line will move to the right, and that means that the prediction will move down, but also the uncertainty on it will get tighter. We'll have to see how many more months this minimum goes on for before it reaches the threshold of 25, and then it will give us a fairly narrow prediction of the size of the coming cycle. But anyway, well done, Kath. Thank you for getting me to do this. So what conclusions can we draw from all of this, apart from the fact that the person that was doing this jigsaw doesn't know how to put jigsaws together? Talking about the sun has passed solar minimum, and I believe that was in September or October of 2019. Solar cycle 25 sunspot regions are dominating solar cycle 24 regions. There are more coronal mass ejections than in previous months, so activity seems to be on the rise. We should expect more, larger and more active solar cycle 25 sunspot regions in the coming months, while we're getting fewer and weaker solar cycle 24 regions. This minimum is not the weakest on record, although it is well below average. And the length of the solar minimum seems to be a good indicator of the size of the next cycle, at least from a correlation point of view. So that's it for this time. There's a lot going on now on the sun, and perhaps as activity increases, I will increase the frequency of these videos to, say, fortnightly or weekly, and eventually when the sun really gets active, maybe even daily. So until next time, goodbye.